students, today we'll see what do we mean by parity check bit coding method. Now this method will come under error detection. Error detection means what? At the receiver, when you receive the data, you are going to detect the error is there or no. You're going to see or you're going to find whether error has occurred or no at the receiver. And this is one of the simplest method, which is called as parity check bit coding. So here we'll have the topic for the day, parity check bit coding. Okay. Now, before going into parity check bit coding, what is parity? Okay. Now, whenever you take a set of data, okay, whenever you take a data set like 8-bit set or 16-bit set, code word, double word, anything you take. So for simplicity, I will take 8-bit. Okay. So bit number one, say 1001 001 1 2 3 4 5 6 7 8. So these are say your 8-bit. Now in this 8-bit code word, whatever you have taken, this is your data. Now depending upon number of ones, means how many number of logic ones you are having. Depending on that, you can define a term called as parity. Parity will give you the number of logic ones in a given data. Now, there can be odd number of ones, there can be even number of ones. So that is why we can have odd parity and we can also have even parity. Okay. Say for example, in this data, whatever we have taken, total number of ones in this 8-bit, 1, 2, 3, 4. So there are four number of logic ones. So 4 is a even number. So you can consider this as even parity. If you are having a data say like this, 0, 1, 0, 1, 0, 0, 0, 1. Okay. So in this, if you see, there are three number of ones. Logic 1, this is 1, 2, 3. And that can be taken as odd parity. So here you understand the meaning of what is parity. A simple thing. It will give you the number of ones in a given data, whether the sum of number of ones is even or odd figure. Depending on that, you can tell whether it is odd parity or even parity. Okay. Now here, parity check bit coding. Parity check bit coding, we are going to see this method, which comes under your error detection method. And this is one of the simplest method. This is one of the simplest way to find whether error has occurred. Okay. So this you have to see at the receiver, and at the receiver you will understand whether error has occurred or no. If error has occurred, then you have to tell the transmitter again to retransmit the data. Clear? Now, before going into this method, we will see what do we mean by error and then error detection, and then we will come to parity and then odd parity and even parity. So as we have seen earlier also, what is an error? So error is a condition when the output information does not match. Remember this, output information does not match with the input information. During a transmission, digital signals suffer from noise that can introduce errors. From noise means what will happen? From noise, the amplitude of the digital signals, whether it is logic 1 or logic 0, will suffer. And because of that, the amplitudes will not be correct, which are representing logic 1 and logic 0. Okay. So that is what has been told here. During transmission, digital signals suffer from noise that can introduce errors in the binary bits, which are traveling from one system to another. That is from transmitter to receiver or from one system, one source to another destination, or from one sender to another destination. Okay. So it is from one transmitter to another receiver. That means A logic 0 bit may change to logic 1 because of this noise, or a logic 1 bit may change to logic 0 because of this noise, and that will be an error. So if you change a particular bit, it will change the meaning of the word. Say for simplicity, if you take your data as 1010, 1010 is nothing but 10, and which is hexadecimally represented as A. Okay, now this data you have got transmitted from transmitter to receiver, and at the receiver, say you receive 1000. This one has become 0. So here, because one bit has changed from 1 to 0, the meaning of this is how much? The meaning of this is 8. This meaning of this is 8, whereas you had sent 10. Now, because one bit has changed, the meaning has changed. No? That is what will happen even if in a code word, or if in a data in information message, whatever it is, binary form, one bit change will change the complete meaning of whatever you have transmitted. That means error has occurred. Okay, so here on these lines, on this basic definition of error, we will see that which is the simplest form of error detection, that will be called as parity check bit coding. Now, after knowing what is error, we will see what is error detection. So, error detecting codes. Whenever a message is transmitted, it may get scrambled by noise, or data may get corrupted. These are some words we always use in communication. Data may get corrupted, or that message may be scrambled. To avoid this, we use error detecting codes, which are additional data added to a given digital message. See here you are telling that you are going to add some additional bits to the given digital data bits. Okay, those additional bits will help us detect if an error has occurred during transmission of the message. A simple example of error detecting code, as I've told you earlier, is the parity check. Parity means what? Number of logic ones in a given data. If the number of logic ones is odd figure, then it is odd parity. If number of logic ones is even figure, then it is even parity. It's simple, clear. Then after knowing what is error and what is error detecting codes, we will go to the method which we are going to see today, that is parity check bit coding method. Now here, what is parity bit? A parity bit is a check bit which is added to a block of data for error detection purposes. As I've told you earlier also, it is one of the simplest method of error detection. It is used to validate, means it is used to tell you that whether the integrity of the data is correct or not, the data which is received at the receiver is correct or not. The value of the parity bit is assigned either as logic 0 or logic 1. That makes the number of ones, that is number of ones in the data in the message block, either even or odd, depending upon the type of parity. So as I've told you, whatever data code word you have, whether you have 4-bit data code word, whether you have 8-bit data code word, whether you have 16-bit data code word, whatever it is, in that complete code word, the total number of ones, if they are even, then you can take it as even parity. And if the total number of ones are odd, then you can take it as odd parity. Okay. So that was again a definition of what is parity bit. Then we will go to see exactly where we are going to put this parity bit in an example of 8-bit code word. Okay. Now you can see this 8-bit code word. This complete is 8-bit code word, whatever is shown in the diagram. This complete is 8-bit code word. This is your most significant bit, and this is your least significant bit. Okay, so we will start with least significant bit is D naught. D1, D2, D3, D4, D5, D6, and D7th will take it as the most significant bit. Okay. Now here out of this 8 bit what you have taken as an example, we will take the first 7 bits for the message bits to give the message. So these are your data bits, or you can also call them as message bits. These 7 bits are going to contain the message. Okay. And the 8th bit, which is most significant, we will take it as a parity bit. This will be your parity bit. Now this bit will indicate, including this bit, how many number of logic ones are there in this total 8 bits. So including this bit, if the logic number of ones are even, then it is even parity. And including this bit, if the logic number of ones are odd, then it is odd parity. And this bit here will indicate whenever you are sending it from the transmitter only, this bit will indicate whether the complete code word is having odd parity or even parity. That you can indicate by either logic 0 or logic 1. That depends on your application and your system. But that bit will indicate whether the total number of logic ones in that code word are odd or even. And like that only you have to receive at the receiver. If the receiver doesn't match to what the parity bit is indicating, then there is an error in the whatever you have received message. Then you have to tell the transmitter again to retransmit. So here, as I have told you earlier, types of parity. You can have even parity. Even parity means the number of ones in the given word, including the parity bit, should be even. That is 2, 4, 6, 8, like that. As I've told you example also earlier for even parity. Okay. Say if you're having a 8-bit code word. Okay, so 8-bit you can show like this. D0 to D7. D0 to D7 will be your message or data bits. This will be message or data bits. And then D8, sorry, D0 to D6 will be your message or data bits, and D7 will be your parity bit. So this will be your parity bit. Okay. Now here, if this data is say 0, 1, 1, 1, 0, 0, 0. Okay. So how many number of ones are there? There are 3 number of ones. Okay. Now if you want to make it as odd parity, you can put this as 0, and it can go as odd parity. If you want to make it as even parity, you can put this as 1, and you can take it as even parity. Okay. So the number of logic ones in a given data will indicate whether the parity is even or odd. If the number of ones are 2, 4, 6, like that, even numbers, then it is even parity. If the number of ones are 1, 3, 5, like that, if there are odd numbers, then it is odd parity. Okay. So here if you see the definition for even parity means the number of ones in the given word, including the parity bit. Okay, including that 8th bit, D7, including the parity bit should be even. Similarly for odd parity means the number of ones in the given word, including the parity bit, that is the 8th bit, D7, should be odd. 1, 3, 5. Okay, so this is the simple definition of what is even parity and odd parity. Then how do you use even parity and odd parity? So that also example you can give here. So here, if you see the theory for that, the parity bit can be set to 0 and 1 depending upon the type of parity required by you in your system, whatever you're using. So the parity bit can be set to 0 or it can be set to 1 depending on the type of parity you require. For even parity, this bit is set to 1 or 0. Okay. For even parity, this can be set for logic 1 or logic 0. That is, the parity bit can be logic 1 or logic 0, so that, or such that, the number of ones, logic ones in the entire code word. Say, for example, if you're taking 8-bit, so complete 8-bit, including the parity bit. So the entire word is even, as shown in figure A down. Similarly, for odd parity, this bit is set to 1 or 0, such that the number of 1 bits in the entire word is odd, as shown in figure B. So what we have shown in figure A. So here is your figure A, and this is the first figure. Now, what is happening in this first figure? You have this 7 or data bits. Okay, so this is logic 1, this is logic 1, this is logic 1, this is logic 1. So you have 1, 2, 3, 4. Okay, and you have made the parity bit as 0. Okay, that means totally there are how many number of ones? Totally there are 4 number of ones. That means it is even parity. It is even parity. Similarly, if you are making the parity bit 1, okay, so then you have to think about your data. Means now you want to indicate even parity, but now we will see the data, how many logic of ones are there. So here you can have 1, 1 and 1. So there are three logic ones. So because there are three logic ones and I want to indicate even parity, then this parity bit I will make it 1, so that including this it becomes 4. Including this it becomes 4. So this is your even parity. Even parity. See, in the first case, the parity bit is 0. In the second case, parity bit is 1. Because including that bit, the number of bits in that complete 8-bit code word should be even. Similarly, if you see the second case, that is figure B here, we'll see the first figure. So these are your data bits and this is your parity bit. Okay. Now, in the data bit, how many logic ones are there? 1, 2, 3, 4. 4 number of logic ones are there. And I want to send odd parity. Okay. So if there are 4 number of logic ones, then the parity bit also I'll make it 1, because including this, it will be 5 number of logic ones here. So 5 number of logic ones, which I can tell it is odd parity. Similarly, if you see the second example, if you see the data bits, how many number of logic ones are there? 1, 2, and 3. So if there are 3 number of logic ones and I want to set odd parity only, then parity bit I'll make it 0, because already I am having odd number of ones in the data. So here this will be 3 number of logic ones and this will also become your odd parity. Odd parity. Okay. So in this way, depending upon the parity type required in your system, you can use even parity or odd parity. Whether you want to send the data with even parity system or odd parity system, depending on that, you are going to assign the parity bit by seeing the number of ones in the data bits. So these are the example of your even parity and odd parity. With this, I think you can easily understand what is this parity check bit coding. And this data, when it is received at the transmitter, and you're telling whether the particular code word is having even or odd parity, then in the receiver, when it is received in the receiver, we have to check the logic number of ones. And if it is even parity, then the logic number of ones should be even. If it is odd parity, then the logic number of ones, including the parity bit, should be odd. If it is not like that, if you're sending even parity and at the receiver, if you're seeing odd number of ones, that means error has occurred. If you're sending odd parity and at the receiver, if you're seeing that even parity has come 1, 0 has become 1, like that, something has happened, then error has occurred. Then at that time, you have to tell the transmitter again to retransmit the data. So here, this is your logic, what is used in this parity check bit coding. So how does the error detection take place in this parity check bit coding? So the theory says that parity checking at the receiver can detect the presence of an error if the parity of the receiver signal is different from the expected parity. As I've told you earlier, If you're sending odd parity, receiver also should have odd number of ones. If you're sending even parity, then the receiver also should have even number of ones. If there is a change, if you're sending odd parity and if the receiver checks out that number of ones are even, then error has occurred. If you're sending even parity and if the receiver checks that there are odd number of ones, then also error has occurred. That means if it is known that the parity of the transmitted signal is always going to be even, and if the received signal has an odd parity, then the receiver can conclude that the received signal is not correct. If an error is detected, then the receiver will ignore the received byte and request for retransmission of the same byte to the transmitter. So it will request for retransmit the same byte to the transmitter. So this is a simplest way of detecting error, which is called as parity check bit coding. Okay. Now here again, I've shown what is the transmitted code. So in the first figure, you can see the transmitted code. So in the first figure, these are the data bits. These are the data bits, and this is your parity bit. Okay, so the data bits are in the data bits logic number of ones are 1, 2, 3, 4. Okay, and this you have made 0. So it is, say we are sending even parity. Okay, and while you are receiving it in the receiver, these are the data bits. Okay, and from these data bits, this data bit 1 has become 0 here. Okay, and here if you see the complete code word, then the number of logic ones are how much? 1, 2, and 3. So you are having 3, which is odd. So you have received odd number of ones. That means error in the code. Received code with one error. Okay. So like this, you can check by this method whether error has occurred or no by counting the number of logic ones in the received code word. Then what are the advantages of parity bit method? The primary advantages of parity is its simplicity. It's very simple and it is very easy to use. Then what are the disadvantages? The disadvantages are as follows. Number one, it is not suitable for detection of multiple errors. Okay, because second, it cannot reveal the location of the error. So it will just count the number of ones in the a given code word, whatever you have received, but it will not tell which bit has changed, where the which bit has changed from 1 to 0 or 0 to 1. So it cannot tell you the location of the bit. So it cannot reveal the location of the error. Number three, it cannot correct the error. It is not correcting the error. It is once the error is detected, if the number of ones are not correct what are received, then it will tell the transmitter to retransmit the data because it is not able to correct the error. So it cannot correct the error. That is a disadvantage of this method. Then what are the applications of parity coding? Is used for error detection in ARQ system, that is automatic request, whatever we have seen earlier, that we are going to request the transmitter to send the data once more. Okay, so automatic request will be doing. Okay, thank you students.